All right, first of all, let me fix this. These are number 45 notes. Angles of polygons. The question is, what's the sum of the measure of the interior angles of a polygon and of the exterior angles of a polygon? So we're going to find and use the sum of the measures of interior and exterior angles of a polygon. So the first thing you get is the definition of diagonal. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. The vertices of polygon PQRST that are not consecutive with vertex P are vertices R and S. So therefore, polygon PQRST has two diagonals from vertex P. It has PR and PS. And you can see them drawn in red. So notice that the diagonals from vertex P separate the polygon into three triangles. So 1, 2, and 3 triangles. So the sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed by drawing all the possible diagonals from one vertex. So in a triangle, of course, there are none. In a quadrilateral, you can draw 1, pentagon, 2, hexagon, 3. So since the sum of the angle measures of a triangle is 180, we can make a table and look for a pattern to find the sum of the angle measures for any convex polygon. So here it is. A triangle is going to have 3 sides. It makes just one triangle. We know the sum of the interior angles of a triangle is 180. A quadrilateral has 4 sides. We can turn it into 2 triangles. 2 times 180 is 360. A pentagon has 5 sides. It can make 3 triangles, so 3 times 180 is 540. A hexagon has 6 sides. It can make 4 triangles, so 4 times 180 is 720. So any n-gon, so any polygon, we can take the number of sides, subtract 2, that will tell us the number of triangles, and multiply that by 180 to get the sum of the interior angle measures. So, first of all, here are the names of all of the polygons. You should know at least 3 through 10 already because those are names that we're familiar with. 11 and 12 are probably new to you. So those are things you want to put into your vocabulary. And then anything above 12, they do have names that are just too difficult. So we just call them an n-gon. So if it has 13 sides, we call it a 13-gon. If it has 14 sides, we call it a 14-gon. So just however many sides dash gon, which is going to tell us that it is a polygon with 14 sides. So card number 71 says the sum of the interior angle measures of an n-sided convex polygon is 180 times n minus 2. And that's what we discovered when we looked at the table. So you just take the number of sides, subtract 2, multiply that by 180 because that will be how many triangles are in the shape. So example number 1. Find the interior angle sums of a polygon. So find the sum of the measures of an interior angles of a convex nonagon. So remember, a nonagon is going to have 9 sides. So we're going to do 180 times n minus 2, which would be 180 times 9 minus 2, which is 180 times 7. And 180 times 7, I'm doing it now on my calculator, is 1,260. So the sum, which we'll just call S, is 1,260. Next, find the measures of each interior angle of a parallelogram, RSTU. So we know a parallelogram has 4 sides. So that's going to be 180 times 4 minus 2, which is 180 times 2, which is 360. So all the angles have to add to 360. So we have 5x times 2 plus 2 times 11x plus 4 is equal to 360. So 10x plus 22x plus 8 is equal to 360. So 32x plus 8 is equal to 360. So we're going to do 360 minus 8 and get 32x is equal to 352. And then we're going to take that 352 and divide it by 32. So x is equal to 11. But are we done? Absolutely not. it says the measure of each interior angle. So we have to do 5x is 5 times 11, which is 55. So angle R is equal to the measure of angle R is equal to the measure of angle T, which is equal to 55 degrees. So that's 2. And then we have 11 times 11 plus 4 is 125. So then the measure of angle S is equal to the measure of angle U, which is equal to 125 degrees. And there we have it. So find the number of sides given interior angle measure. So the measure of an interior angle of a regular polygon is 150. Find the number of sides in the polygon. So it's regular, so that means that all the angles equal. And so that means that we need to find the number of sides, which is n, right? So we know that the sum is equal to 180 times n minus 2. And in this case, our sum is going to be 150 times the number of sides because it's regular and each of those angles is 150. So 150 is equal to 180 times n minus 2. So 150 n is equal to 180 n minus 360. So then that's going to be negative 30 n is equal to negative 360. So then n will be equal to 12. So this is a figure with 12 sides. And if you recall, 12 sides is a dodecagon. So the sum of the exterior angle measures of a convex polygon, one angle at each vertex is 360. So it doesn't matter how many sides it has, the sum is always 360. So find the value of x in the diagram. So let's look at the x's. We got 5 plus 4 is 9, plus 5 is 14, plus 4 is 18, plus 2 is 20, plus 6 is 26, plus 5 is 31. So that means we're going to have 31x. Then we got minus 6 and minus 5, that's minus 11. Plus 3 is minus 8. Minus 12 would be minus 20. Plus 3 is minus 17. Plus 5 would be minus 12. And that has to be equal to 360. So then we're going to add 12 to both sides. So 31x is equal to 372. Divide both sides by 31. And x is equal to 12. So remember, the exterior angles have to add up to equal 360. And then lastly, find the measure of each exterior angle of a regular decagon. So regular means that it has all equal angles, and then decagon means it has 10 sides. So we want exterior angles. So we're going to do 360 divided by 10, and that's going to be 36. So each exterior angle is 36 degrees.